The element uranium is named after the planet Uranus. Its atomic number is 92 with an atomic mass of 238.02891. Its mass number is also 92. Uranium will always have a positive charge. Its valence will always be either 2, 3, or 4, or 5, or 6. Valence 4 and 6 are most common. Uranium is a rare earth metal. To the naked eye, uranium looks like a rock. On the atomic level, it has 92 protons and electrons and 146 neutrons. It has a hardness of 6.0 on Mohs hardness scale. It has a luster of greasy, pitchy, or dull. Its streak is brownish black, gray brown, or olive green. Uranium's color is either greenish, brown black, steel black, or plain black. It has no odor. Uranium reacts with almost all nonmetals, except noble gases and their compounds. Reactivity increases with temperature. Hydrochloric acid and nitric acid dissolve uranium. Non-oxidized acids other than hydraulic acid attack the element very slowly. In uranium's hexavalent state, it is very soluble and travels with water. Uranium in tetravalent state is insoluble and is essentially immobile. Centrian bacteria is able to reduce uranium from its hexavalent state to its tetravalent state, thus decreasing its solubility and trapping it in the soil underground. When pH of uranium-6 increases, it is converted to a hydrated uranium oxide, hydroxide, and at high pH levels it becomes an anionic hydroxide complex. When carbonate is added, uranium is converted to a series of carbonated complexes. If pH is increased, one effect of those reactions is increased solubility of uranium in the pH range of 6 to 8. In fact, that has a direct bearing on the long-term stability of spent uranium dioxide nuclear fuels. Uranium is typically found in the Earth's crust, where it is 50 times more abundant than silver and 500 more times more abundant than gold. Uranium is found almost everywhere in rock, soil, river, and oceans. There are two methods to extracting uranium. First is conventional open pit or underground mining. Second is chemical processing, in situ leaching, depending on the depth in the ground and the seam of the rock containing uranium. The deposit is either mined using surface or subsurface mining. Uranium has many uses and purposes in the world. In civilian use, it is used for commercial nuclear power plants that use uranium-enriched fuel. In military uses, it is commonly used for high-density penetrators, for example, ammunition and nuclear bombs. Finally, uranium is also used in shedding material in containers using transport radioactive materials. In conclusion, uranium is one of the rarest elements in the world and can be used for very destructive purposes.